DevelopSec, Developing Security Awareness with James Jardine, brought to you by Jardine Software. Hi, and welcome to episode 13 of the DevelopSec podcast. I am your host, James Jardine, and today I wanted to start the discussion about what cross-site scripting is. Well, we've seen it start to kind of fall down the list a little bit of the OWASP top 10 over the past few years. It's still a pretty significant attack vector and one that we see all over the place. And obviously, cross-site scripting is something that, we can't cover in 5 or 10 minutes the entire process of what it is. So I really just want to start the discussion of what it is and then some of the effects that it can have to kind of highlight how serious of a vulnerability it really can be, something that we don't want to really just overlook. So the idea behind cross-site scripting, if you listen to one of the previous podcasts where we talked about SQL injection, it's very similar. It's an injection attack. It's just an injection attack against JavaScript and HTML that gets executed in your browser. So the idea is that somehow there's untrusted input that gets sent to either the web server or stored in a back-end database, and that untrusted input then gets displayed back down to the browser without being properly protected or segmented to say this is data, this is an executable code, and it allows an attacker to put in JavaScript or other HTML to rewrite the page, make things happen, maybe redirect the page. It pretty much gives an attacker full control of that web page now. So no longer does the developer have control over what that page does. Now the attacker controls that. All the way up to hiding all the current content and then displaying something completely different. We can do that as well. So again, there's 3 types. There's reflected cross-site scripting, and that's where I send it up in either a query string or it could be a form post, but most commonly it's a query string in the URL, and the application takes a value out of that URL, out of the query string, and returns that back down to the browser, right? Maybe you pass up a username, and it sends that username right back down to the screen to say, hey, welcome user, whatever, but it pulls it from there. It doesn't pull it from the database. If I can manipulate that value, then there's a chance that I can run cross-site scripting, create my own JavaScript attacks, and now we've got access. Reflective is much more of a, hey, I want it to happen now to this person, where it's very targeted. So I'm going to take it, and if it's a link, I can just email it to somebody, have them click the link, and it runs that code. The second type is persisted cross-site scripting. Persisted means that we're going to store it for later. Now, that's not the attacker actually storing it for later. That's the web server or that backend storing it somehow, whether it's a database, an XML file, whatever the backend storage mechanism is. They're the ones that are actually going to store our payload. And then when an unsuspecting user comes across our page, it then loads that value and executes it in the browser. So think of like a forum site. I go ahead and post my comment. My comment has cross-site scripting, but I'm not directing anybody to it. I'm waiting for somebody to come along and view that post, and anybody that comes and views it will have that code executed on their browser. This is good for if you're trying to get an admin to do something, or take over an administrator account. Wait for an admin to view your post, and then maybe it steals their session cookie and sends it to you so you can log in as the administrator. That's just one example of what you could do with it. But that is kind of the idea behind the persisted kind is, hey, I'm going to stick it up there, and it's just going to constantly hit whoever comes across it, and we'll take advantage of them. We tend to see more of the reflective with phishing attacks, where we can send out a link, we obfuscate the link, so that way you can't really see that there's malicious code within the query string, and then get people to click on that link, and then it runs that code. The third type of cross-site scripting is DOM-based cross-site scripting. With DOM-based cross-site scripting, it's similar to reflective, but we're not actually relying on the browser directly to take that value and execute it as JavaScript, what we're doing is we're actually relying on the DOM, the document object model within the browser, to actually parse the value and execute it that way. And what's interesting about these is all of them have different signatures and techniques that they can be employed. So things that you'd think you'd protect against for a context of HTML, and we'll talk about context in a moment, doesn't necessarily work in a DOM-based situation, because in DOM, I can write my value to the screen, right? It goes to the browser, nothing happens. It doesn't execute it right away, whereas it does on the other two. But if I have a JavaScript function on the page that then calls that value, at that point it actually gets executed, and now we've got the cross-site scripting attack. So it's a little bit different. You don't see it as much. Reflected and persistent are definitely much more prevalent. But DOM is there, and can be pretty tricky to find, actually. So there's a bunch of different contexts that we have when we talk about cross-site scripting. You have HTML context. So if I'm going to try to attack just a regular HTML element, the HTML tag, a span tag, a div tag, any of those things, right? That's where I'm putting in a script tag. You've also got attribute-based. So if you've got something like an image tag or a link tag, and you're setting the value that the user set up into there as an alt attribute or some other attribute, can I break out of that attribute and then start writing my own attributes? Can I start writing my own events and say, on click, do this? And now I've got cross-site scripting, because now I can get something to happen when somebody clicks my link. Another good example is image tags. If I can write something into the image tag, then can I add a on error do this? And then if my source is the image that's supposed to be there, I put in some source that won't exist, and then I say double quote or whatever character I need to do to break out of that attribute, on error alert cross-site scripting. Oftentimes you'll see, especially in reports, we talk about alert boxes, we see alert boxes. It's usually just the easiest way to display it. Obviously, it's not very devastating, but that's probably one of the least things we can do with cross-site scripting. Also, you've got comment context, right? So if your data is coming down into a comment, if it's coming down into a URL, if it's coming down into CSS for cascading style sheets, a JavaScript context, if it's coming into JavaScript, right? We've got all these different and the biggest thing to know between these is, as an attacker, I need to understand the context to be able to understand how I'm going to attack that specific instance. Because if it is HTML, there's different characters I'm using than if it's attribute. HTML, I'm looking to close out a tag or add a new HTML element tag, whereas attribute, I'm looking to close out an attribute and do something different there. This also makes it a little bit more difficult for the defenders, because you can't just say, oh, well, for HTML encoding, just encode the less than and greater than symbols and you're good. Because when we talk about attribute, double quotes, single quotes, spaces are all of concern, because those are delimiters. Whereas less than or greater than really doesn't matter in an attribute-based context for me. So that makes it a lot more difficult. So you want to use some sort of library that's dedicated to help doing this. .NET has a library that's out there that you can use, the anti-XSS library, which is now the web protection library that's out available. You can use that, and it's got all these different encoding functions as a developer to be able to encode this stuff properly. So you can say, hey, this isn't an attribute, so I want an HTML attribute encode this. It's just HTML, so HTML encode or URL encode. Same thing, the Asapi library for Java and some other languages, same type of setup. We have this ability to import a library, and then all the encoding functions are there for us. So as a developer, we need to make sure that as this data comes down, we're encoding it for the proper situation that it's going into. Just like when we talked about SQL injection, how I need to make sure that I'm properly protecting my SQL query to say, this is data, this is command, That's what we're doing with these encode methods. When we do the encoding on it, we're saying, hey, these characters here are going to be data. Don't treat them as a delimiter or as an actual opening bracket or closing bracket or anything like that. Just display it on the screen. And that's the key with a lot of these injection attacks. It's knowing where it is and how to defend against it to make sure that we're defending in the right context. And sometimes we have to mix contexts, and that's fine, but you might have to chain two contexts together because it's a URL and it's JavaScript, or it's URL encoded, but it also has to be attribute encoded or something similar to that. We can have those situations pop up. In the most case, it's fairly simple to eradicate cross-site scripting. It's just a matter of effort on the developers to be able to go in there and understand that when you're taking data and displaying it to the screen, how to encode it. Now, fortunately, we do have some nice view engines that are out there that'll help make this a lot easier. For example, Razor, which is used for .NET, pretty much all the stuff that you do in the view there is encoded automatically for you. So now we don't have to think as much about it. And we're starting to see more of these engines come about that, hey, look, you're putting this data down here. We'll go ahead and encode it. We already know what we're doing. We'll encode it for you. You don't even have to think about it. Whereas in the olden days, it really wasn't like that. You had to say, I want to encode this value. And every place you displayed it, you had to encode it. So that obviously was a lot more work and opened up a lot more chance to miss it. Whereas now, when it's automatically encoding, unless you do something specific, like do a raw HTML or something like that in a Razor engine, it should be automatically encoded for you, and it's very difficult to find a cross-site scripting flaw there. So very similar to what we see with Hibernate or some of these other ORMs that exist for SQL queries. We have these new engines that are coming out for the front end for cross-site scripting. So you might wonder, why does it matter? Right? It's cross-site scripting. Every time I ever see it, it's an alert box, or somebody goofed around and they changed the background on my page, or they did something benign. But really, cross-site scripting can be the entryway into your network. Not only just your computer, but it actually could be the gateway into your network. So if you've got an enterprise, if I can trick some user inside the network using a phishing scheme to click on my link, and I can execute cross-site scripting on their machine, well, then that gives me a foothold to then try to actually take over their machine. And then if I can do that, then I can then start scanning the internal network as if I'm actually on the network. So now I've bypassed all your fancy firewalls, all these other rule sets. Now I'm as a user on your system, and anything that user can do, now I can do. So yes, we always see an alert box, or we see something that's fairly simple, but we can actually have cross-site scripting do a lot, all the way to the extent of pivoting in and gaining access to your network. We can also steal keystrokes, so we can install keyloggers, so that way if you type in passwords, we can collect those. We can prompt boxes through cross-site scripting to be able to say, hey, your application's timed out, please retype your password, and have that password sent to the attacker. The attacker can grab your session ID if it's not properly protected to be able to try to hijack your session. So it's a fairly serious vulnerability that doesn't really talk a lot about all that it can do. We really only talk about, we can rewrite the JavaScript. And I think a lot of people kind of underestimate the power that cross-site scripting has. It's been high on OWASP for a long time, and it'll stay there because of that power. But because of the way we have to demonstrate it in reports, oftentimes it comes up as, this is an alert box. Management doesn't think that's very serious, so they go ahead and try to avoid it. We can work on fixing something else because that's just an alert box. No big deal. Okay, yeah, maybe it's a reputational problem, but we can get around that. So there's a lot to talk about with cross-site scripting. This was just kind of a brief overview. We'll definitely spend some more time in some future casts digging a little bit deeper into some of the examples of some of the different ways that these can be done, some of the different attacks that can be performed using cross-site scripting, but I just wanted to start it off and get people kind of thinking about it as we start talking a little bit more about it going forward. I thank you for listening, and we'll get the next episode up as soon as possible. Thanks again. You have been listening to the DevelopSec podcast with James Jardine. Follow us on Twitter at DevelopSec and visit our website at www.developsec.com for more episodes and information.